Hello, this is Mr. Bradley, and this is the first day of physics at Ralston Valley High School. Physics first semester will be all about motion, studying how things move and the causes of that motion. We'll learn some conservation laws. Really, it's like what we call kinematics in the world of physics. And when you talk about motion of things, the very first thing you really need to talk about is just that basic concept of speed. Speed's a word that we use in our everyday life, and most people have a pretty good familiarity for what speed means. Oftentimes it's just thought of as how fast something is moving. In physics world, or in physics terms, speed is really the rate at which distance is covered. If you remember from your math class, a rate is basically when things change over time, and so really you're talking about how distance changes over time. One of the times that we think about speed, we really think about like our average speed, which is, how much distance you cover over how much time it takes you to do that. The equation that we would use to find average speed, V average, would be equal to just distance divided by time. Now, I need to talk about a couple things here. This letter V right here, we're using V because when we talk about speed and we talk about velocity, they're very similar concepts, and so we just use the same letter for both of them. I'm putting this little subscript down here, average, to let you know that I'm talking about, an average speed, not necessarily an instantaneous speed, which will be the next one that I cover. So, this would be like if you drove, say, from Colorado to California, and you took the entire distance that you covered and you divided by how much time the whole trip took you, you could find what your average speed was. You could do the same thing if you drove from Ralston Valley to your house. You could take the total distance that you covered and divide by the time that the total trip took, and that would be telling you what the average speed of the whole trip would be. Because you're talking about a distance divided by time, then the units of average speed are a distance unit divided by a time unit. So we're all very familiar with miles per hour. In physics, we talk a lot about meters per second because meters is the metric unit of distance that we prefer to use, and seconds is the metric unit of time. You also might use feet per second, you might use kilometers per hour, and then, of course, there are hundreds of other speed units that we might encounter. But these are probably the four main ones that we will deal with. Okay, so average speed is, really like how fast you're going over a large distance and over a large time. But if you really want to start thinking about like how fast you're going at a moment in time, then we use the concept of instantaneous speed. And really it's similar to average speed in thought, but it's just over a very small time interval. So you might talk about the distance that you cover in a tenth of a second. And if you take that distance divided by that tenth of a second, then that gives you an idea of just how fast you're going really at that moment. This is what the speedometer in your car tells you, or a radar gun that a police officer might use. This is just telling you how fast you're going at a moment in time. Okay, so this is the most basic equation that we're going to use in all of physics. We're going to be using the concepts of average speed and instantaneous speed in much more complex problems. But in reality, this is just where it all begins. Okay, so let's do an example. This problem right here is a pretty standard, very simple kind of problem that you would use physics to solve. The problem says a man travels a distance of 25 miles in 3.4 hours. What is his average speed? I want to do this example right now just to show you not only the process that we want you to follow, but also just how we want problems to look, and we can talk about some things. So the first thing we do is we read through the problem and we just make sure we know what everything is. This first information right here, a man travels a distance of 25 miles, of course tells me the total distance that was covered in this situation. So I'm going to go ahead and write that down right here. That's one of my givens, that the distance traveled is 25 miles. Make sure you write down the letter, the quantity, and the unit that goes with it. I have another quantity that was given here to me, 3.4 hours. Now, it doesn't tell me exactly what that represents, but I can reason through, using the context of the problem, that that's the time it took for him to cover this 25 miles. I mean, that's what the problem says. So I'm going to write that down right here, that the time it takes this man to do that is 3.4 hours. We abbreviate hours with HRS. All right, well, the problem is asking me to find average speed. That's what I'm looking for. So I'm trying to find average speed. Okay, so what I'm doing here is I'm basically showing you the givens, and I'm showing you what I'm trying to solve for. The next step in this process is just to identify the equation that I'm going to use. Well, I only have one equation at my disposal right now, and that is that average speed is total distance covered divided by time it took to do that. And I have those variables, so I'm going to go ahead and substitute those variables in to that equation. Now this is a step that a lot of kids want to skip, and I understand that because it seems like overkill, it seems time consuming, it seems tedious, but it's important. It's one of the most important steps, because this says this is the math I'm going to do, and these are the units and how they're going to work out, and that's a big part of the problem solving process. So you absolutely have to show this in your work. All right, well finally at this point I can just use a calculator to evaluate what this is. I'm going to take 25 divided by 3.4. When I do that, I get 7.3529. So 7.3529. And there's a lot of other numbers there too. I'm putting dot, dot, dot to tell you that there's more there. I'm just not writing it all down. That is kind of my unrounded answer. I'm going to go ahead and need to round my answer to the appropriate number of significant figures. That's something that we'll cover much later. But I'm just going to tell you right now that my answer, I'm going to round it so that it's 7.4. So this is 7.4. And then I need to include the unit of my answer, which is miles per hour. Okay. When this man did this trip, he averaged a speed of 7.4 miles per hour. Now, does that mean that he was going that speed everywhere along the way? Probably not. He probably was going faster at some place and slower in other places. He might have stopped. He might have been going super fast. It's really hard to say. This is just on the average over the whole trip. This is what his average speed was. You could use this number then to predict how far might he go in 6 hours, or how far might he go in 10 hours if he could keep up this average speed. That's what a number like this or an answer like this is useful for telling. Okay, well that's what this next problem is trying to get you to see how we would do that. The problem says if the man wanted to do the same 25-mile trip with an average speed of 8 miles per hour instead, how long would it take in hours? I'm going to use the same equation that I used before, but I'm going to have to rearrange it algebraically to do that. I'm going to go ahead and pause the video so that I can work out a solution and then show it to you. I would like for you to pause the video and see if you can work it out on your own first, and then you can check against my solution. So, pausing now. Okay, I'm back. So, the correct answer here is 3.1 hours. Okay, hopefully you got that right, but hopefully also your formatting looks very much like what I have right here. What I did is I wrote down the fact that he's going to travel 25 miles with an average velocity of 8 miles per hour. Now I'm looking for the time it takes for him to do that. I used the same equation that I used before, but I rearranged it so that it's in this form. If you don't know how to rearrange equations, it's something that you're going to be doing a lot in this class. So, you know, we need to make sure that you are pretty adept at it. Ask your teacher for some help, or look for some other resources as well. But I now take the distance that he traveled divided by his average speed, and I come up with this answer. Now, an important thing here is notice how the units work out. This miles right here cancels out with that miles down there, which leaves per hour in the denominator, and algebraically that really means that you just have a unit of hours. This is really why we do that step, so you can see how the units are going to cancel out and make sure that you have your answer in appropriate units. So it's going to take him 3.1 hours, which makes sense because before he went 25 miles in 3.4 hours at this average speed, and now he goes faster, and so it takes him less time to do that. You should always check the logic of your answers to make sure it makes sense, because if it doesn't make sense, then you probably did something wrong along the way. Okay, so now I have another example where we're going to use the same equation, but we're going to use it in a little bit different form. So Usain Bolt, who's a pretty fast dude, ran 100 meters in the 2012 Olympics with an average speed of 10.38 meters per second. If he could keep up the speed for 12 seconds, I want to know how far he would run in meters. Again, I'm going to pause the video so that you can practice through it yourself, and then you can check your answer or check your solution against mine in a moment. So pausing now. Okay, so my answer is 125 meters. Basically what I'm saying here is that Usain Bolt ran with an average velocity of 10.38 meters per second for 12 seconds. The way I find out how far he would go is I take the average velocity and I multiply by the time. Again, this is the same equation that we learned before, but rearranged for a different, in a different form. And when I take those two numbers and multiply them together, I get 125 meters. Notice that the number 100 meters here was not important to the problem. I was just telling you about the 100-meter dash, but that wasn't important to the problem. That wasn't something that I needed, so I didn't write it down. What was important was his average speed and how far he could run in 12 seconds if he ran with that average speed. So obviously you can see he'd run more than 100 meters, which means he must have done the 100-meter dash in less than 12 seconds. Pretty fast running speed, by the way. Also, I want to make a point that this is his average speed. That's not how fast he was going anywhere along the way. He started from 0, so his initial speed was 0. And somewhere along the way, he was going faster than this. He had some instantaneous speed that was much faster. But this was just what his speed was on the average. Okay, well, hopefully this video helps you understand things a little bit better if you weren't able to understand them the first time. Hopefully it also, if you missed class on the first day of school, this will help catch you up a little bit. It's going to be a good semester. We're looking forward to having you guys be a part of the Ralston Valley Physics program. And just good luck and have a great day.